I'm going to show you today, it's small and medium-sized companies. The big companies rely upon big data. They have a lot of cases or examples or instances, how we call it. So, for instance, if you have 100 sales opportunities per month and only 10% are conducted or closed, then it's quite acceptable. In small companies, when you have perhaps 8, 9 business opportunities and only one or none the deal is closed, you can imagine that this can be quite difficult for a small or medium-sized company to be successful on the market. And they all compete on the same market. So you know how many small and medium-sized companies there are in European Union and wider? More than 90%, even 99% in Slovenia. So quite a lot, quite a big market and opportunity to solve these types of problems. We call these problems, organizational problems, ill-structured problems, or even wicked problems. I like that one. So it means that we have incomplete data, we have missing data, we have a lot of changes coming from the environment affecting the organization, and we require deep understanding of such problems. So imagine that you're a sales consultant in a small company and you need to report to your managers each month how many open business opportunities will be closed that month, and you're only 20% accurate each month. It's a big stress. It's a big stress for the sales consultant, and it's a big stress for the managers as well, because they make decisions upon that forecasts. So bad decisions at the end. So in business to business especially, it is crucial to be able to support sales consultants to understand that process, to make better decisions. Business to business sales is a complex process. It's a much more complex process comparing to the business to consumer sector. We have internal rules of both organizations. We have negotiations about legal formalities, price, implementations, and usual methods are not efficient in SMEs. We have lack of quality data. Usually these data about business to business sales are stored in companies' customer relationship management systems. But these are qualitative, descriptive data, and usually they're subjective. The values of these attributes are subjective and varies from person to person, so from sales consultant to sales consultant. And of course, in business, especially in small business, there is really low technology acceptance among users. I was really lucky because the previous keynote, Dorothea Wiesmann, made really good introduction into lack of understanding and into need of interpretable and explainable machine learning models. So this is what I'm going to talk about today. As said, there are many methods for sales forecasting, but in practice, we see that subjective judgment still prevails. What were our goals? Our proposition was that we can build machine learning models from past sales history and use it to support sales consultant in business opportunities evaluation, and especially in understanding the process itself. So business to business sales forecasting can be modeled as a simple binary classification problem. The business deal is closed or is not closed. Well, later on you will see that it's not that simple, but for the start we wanted to model the problem like this. And we wanted to build a transparent interpretation of individual sales opportunities that will improve understanding of the process and contribute to overall business results. So this means that we wanted to reduce forecasting error at first, so that not just 20%, as was seen in empirical studies, were correct, but more. We wanted to learn from sales history, and we wanted to support organizational learning by interpretable machine learning models. This has never been done so far as we know. We approached this a little bit, different, innovative, with action design research methodology. How many of you have heard about action design research? Not many. This is a research methodology which combines action research, which means that we are trying to implement something in an organization, in a company, and then evaluate how it affects, and then rethink, readjust that method or information system, and then try again and again and again. And of course, design science research with which we design an information artifact, in our case, the machine learning model, so the predictive model. We followed the CRISP DM standard, and we coupled the predictive model with the explanation methods. We used two explanation methods, explain and IME, and I will explain the explain method later. So this figure depicts our research proposed model with which we derive attributes or features of our sales history from companies' CRM, and we involve users and researchers at the same table. So action design research is actually a participatory design, and we involve users not just to evaluate what we did, but to develop, so to think about, develop, and evaluate methods, and of course eventually use it. So users and researchers try to model the insights in the predictive models, and machine learning predictions are explained which powerful visualization tools, or very simple powerful visualization tools. Then the actual predictions are made, and then the realized business-to-business sales are fed back into companies' CRMs, so that we can see how good the prediction was. Here you have the single loop learning depicted and the double loop learning depicted. Single loop learning actually means individual learning based on trial and error. So we learn from machine learning model, we learn something new, and we adjust our behavior to maximize our goal. But double loop learning is something else. It is usually done in a team setting, and it's also called the organizational learning. So it's when we challenge our anchored mental models, so the way we used to think, and we accept that some new knowledge can challenge our mental models. Okay. General explanation methods were developed at the Faculty of Computer and Information Science in Ljubljana by Robnik, Šikonja and Kononenko, and Strumbel and Kononenko. Mr. Strumbel had his speech yesterday. And basically it's the sensitivity analysis where with explain method we just hide one input variable and see what happens at the output. And with the IME method, it's a little bit more complicated and computing exhausting, and we try to find how a set of variables impact the outcome. This is how we try to have the model level explanation, or as Dorothea previously said, it's interpretation, and example level explanation, which is explanation. So overview of what the whole predictive model does, and to understand the past sales on an example level, the new examples, so the open business opportunities, and of course the wrong predictions as well, because we can also learn from our mistakes. The core of action design research methodology is model building, intervention in organization, and validation. I can say that action design research was first published in 2011 by Sign and co-authors, if anybody wants to know. We used Orange basically for preparation of data and for visualization and analysis of data, and then our core Learn for model building and explanation. Data preparation task is usually the most demanding task within the CRISP-DM method or standard. First, we were relying upon CRM that we gather all sorts of attributes there. We will for sure have something to work on, to build a model on. And I have to say that at the beginning, we have 3 companies in which we were trying to do this. But at this stage, 2 companies just said, we don't have the time to do it, we don't believe you that you're going to help us, and stepped out. So we only had 1 company left. Here are depicted all the attributes that we have got from the CRM and from theory that are addressing the business-to-business sales. So 32 attributes describing the economic status of a client, 9 attributes describing features of a salesperson, and then 23 attributes describing internal interpretation of sales opportunity, and then 6 attributes about the business relation and external stability of economic environment, 8 attributes, quite a lot of attributes. First, we have trained the models and saw that the models that were trained by just taking the attributes that the company had collected in the CRM was performing even worse than their salespersons. So this was not going to be a good thing. Then we realized that the data collected in the CRM is very subjective. So the values of the attributes were very subjective. Each salesperson had their own understanding of what the authority means, what the product means, and stuff like that. So we conducted several workshops in which we created a baseline of understanding of all the sales team in the company. So what exactly each attribute means, the description, and what the values means, and how to assign the values of these attributes. At this point, we decided not to intervene in the CRM, but to collect the new instances in plain simple Excel, and then use this to train the further models. So the final data set, this is just an excerpt of this, has the client status, deal type, strategy, deal, cross-sell, upsell, importance of a client, and finally, whether the deal is signed or not, yes or no. We had collected 448 cases, 22 attributes, 1 class attribute, lost or won, and you can see it's a balanced set, so 49% of won cases and 51% of lost. We used 80% of cases for the training set and 20% of cases for the testing set, and this data is publicly available, so you can use it to, I don't know, train, use it in at your university or whatever. Then we performed the feature selections. We used the combination of the filter and the wrapper methods. So this is the classical filter method, ranking of attributes, And as you see, the popular criteria, information gain, gain ratio, gain index, random forest, and relief F. And of all these 22 attributes, only the first 5 are really important, so really contribute to the outcome. Some of these attributes or their contribution were really surprising because, let's say, familiar of the vendor, competitors, and deal size. The salespersons thought that this would be the most influential, but as you can see, almost no contribution to the outcome. Already in this phase, the sales team realized how important it is to collect good quality data, how to communicate, because new insights were brought into the process. The second one is the combination of the filter and wrapper method, and is actually the optimization process about feature selection that we have developed, and it goes like this. We were incrementally added features ranked by relief F to the 3 classifiers and calculated classification accuracy on the testing data. So you can see the classification accuracy by adding the number of features is at some point is increasing, but then at one point starts to decrease. So it actually presents some noise in the model. And then we perform the vice versa with the wrapper method. We then excluded attribute by attribute or feature by feature, and also again tested the classification accuracy on the testing data and saw at which point the classification accuracy start to decrease. So we find some kind of a balance for each algorithm by itself. So it's you can see here the random forest needs approximately 9 attributes for the maximum classification accuracy, and we see the naive Bayes. It goes like this, approximately the same, and decision tree, well, actually the classification accuracy there is quite lower. About the training instances selection, we had totally the opposite problem than we have heard at this conference. We always hear there are too much data. We cannot use all this data and store all the data. You don't know when it is going to be useful for you. But here we have really small set of instances. Approximately 10 to 15 instances were added per month. This is really small. And of course, the quality of these instances are not that good. If you want to train a good model, an efficient model, then you really have to have a good training set or data set in general. Usually in machine learning, we want to have randomly selected data into data sets. But here we cannot do it. So we needed visual analysis of the instances itself to get as much variability in these instances to train good models. This is the proximity measure used from a random forest and visualized on this graph. So you have training instance number here and here. On the left-hand side, we see a good data sample, so varies a lot. And on this side, on the right-hand side, or your left, you can see that there we have an issue with the data. So we visually know that something's going on with that data, and we can discuss it with the sales team. Here, we had the problem that the sales teams have mailed out an invitation, so it was marketing purpose, so all the instances were the same. So we excluded it out. Evaluation of machine learning models, once they were done, usual, you know all this. So we checked out for random forest, naive Bayes, random forest for its robustness, naive Bayes for simplicity, decision trees, support vector machines, and neural networks. And we performed these tests, 30 runs, 10 cross validation faults, so default setting in orange, and these were the results. So best performing was random forest. Interestingly, secondly best was naive Bayes. So why the explanation? Because the top performing black box models like random forest or neural networks for that matter are not interpretable. So we don't understand it. So the users, of course, don't trust it. And if you remember, I said that we needed to build the understandable models. So this is the visualization using IME and explain. In this graph, it's explain method. For the instance 14, model is random forest, status is 1. We can see here attributes, sales complexity, seller, existing client solution authority, and here the attribute value for this particular instance. And here we can see how the contribution, positive or negative contribution of this special instance in the model. And this is the average negative and positive contribution to the outcome with status 1 for this instant. On the other side, we have the complete model. So this is basically the visualizations that we used to explain to users what the models are doing, and of course to have, let's say, a starting point for discussion. We can do all sorts of what-if analysis with this visualization, let's say analyzing new sales opportunities. In this picture, we have the currently predicted probability to win the business only 0.49. And we were trying really hard to sell or to close this deal. So we tried, what if we, this is really negative, we are trying to sell the solution B, we cannot change that, but we can change the seller, how the changing of the seller impacts the outcome, and you see it impacts so that the change predicted probability changes to 0.85. We can drill down to specific business questions. So what are actually the features that impacts the most the clients with the status new, so the new clients. So we have only 158 instances here, and we see how so negative impacts and positive impacts of these attribute values when the client is new. We can do learning from the wrong prediction, and I have to be quick. So you can see we have a lot of support for discussion with the sales team, and it's really easy. I want to show the results of implementation in this company. So we tried this from July 15 to August 16, and what you see here is the curve of machine learning predictions, which is pretty bad. But we have here the consultant, one of our team. He used machine learning predicting, and based on that, he made the predictions and offered it to the sales team at the company. We also have here the initial prediction, the red line, of the sales team without using the machine learning predictions, which is in cases even worse than machine learning. But I will show you this green line is when they started to trust the machine learning predictions and using them, and look what happened when they used the insights from the predictive model. So together with the predictive model, their forecasts really improved. On the second graph, I have this from September 16 to June 17, and you see that this green line is not always as green as we wished to be, but yeah, it supports the reasoning, and by that reasoning, the sales team were able to detect that one line, and this is the sales slippages, so the deals that slipped to another month or 2 months, and we couldn't do this currently by the predictive model. Here you can see how their initial baseline prediction differs from the consultant using machine learning model, and of course their revised, the sales team revised prediction were quite higher, and these are the slippages. So, the take-home message. What we had to do, we had to really engage closely with the users. We wanted to make them trust the technology, make them use the predictive model, and we succeeded in that. Of course, there's a great deal of effort put into that because of course the learning curve, and of course the users have to see the business results and then they trust. In practice, slippages are not solved yet. We see that the sales teams do understand this better, the predictive model, but we are working on that to implement this in the predictive model as well. And of course, there is a very vibrant business environment, changes in the environment. In machine learning, we call it also a concept drift. So new and new attributes can arise, and we have to try to implement these new attributes in our predictive models. But of course, there is the cost of these experiments. So currently, we are experimenting what is the minimum instance number that we can assess good predictive model or train good predictive model, and what is minimum set of attributes. So minimum set of attributes is very important that business users understand the model. Research team, of course, I didn't do it by myself. My colleagues, Marko Robnik-Šikonja from Faculty of Computer Science and Computer Information Science, University of Ljubljana, and Marko Bohanec from the company Salvirt, my PhD student, and of course myself. These are the two references that I invite you to read, most relevant for this talk, and of course all the sales team from the company that I was mentioned. So thank you very much for listening.
We have 3 minutes for questions. There's nothing on the platform, so if anyone wants to ask something, you can just raise your hand and I'll...
Somebody's happy outside.
Thank you very much for the presentation. It was really interesting. I just have one question to the training instance selection. So basically the color gradient, that was the variance in the training data, or what was the color gradient?
The color gradient was the variety of the instances. So basically, if the instances were very similar, they would be black.
Okay,
yeah.
So like
so
if it's like 5 instances black, that means they are all the same.
Exactly.
And then you sample them out, so you just have like a
Yeah,
kind of
we
random
looked
sample.
into it, why they are so similar, and if we realized that it was something like marketing campaign, then we just sample it out.
Ah, okay. Thank you.